Welcome to the course EE163 Computers and Programming. Course teachers are Sir Iqbal Azim and Muhammad Umar Sajid. This is Muhammad Umar Sajid speaking, and in this course we will be learning how to write software programs which are run on the computer. A program is a sequence of instructions that can be executed by a computer, and every program is written in some programming language. C++ is one of the most powerful programming languages available. There are other programming languages, but in this course we will be focusing primarily on C++, and it gives the programmer the power to write efficient and structured programs, and those programs can also be object-oriented programs. And what is object-oriented programming? We are going to discuss that in future lectures, but in the initial lectures we will be discussing only structured or procedural programming. To look at the course outline of this course, go to eet.neduet.edu.pk, then go to this drop down menu and go to undergraduate, and then click on this link syllabus 2014-15, and then you will see a PDF file which is being opened. And if you scroll down to EE163, you will see the course outline of computer and programming. Before midterm, we are going to discuss the structured programming part. We might be discussing some introduction and history of computing, some brief history and development, this development environment. In this lecture, we are going to discuss how to install the integrated development environment, and then we are going to see some building blocks such as data types, variables, and their representation. Then we will be discussing the structured programming part, in which we will be discussing some conditional statements such as if else, which depends on some logical condition being true. And we'll also discuss if you want to run a software code multiple times, then you need to run something known as loops, such as do while loops or while loop or for loop. They also depend on the logical condition being true for them to run. Then we're going to discuss the arrays and vectors, and we are going to discuss functions, which are essentially blocks of code with a name, so that you can, instead of writing that code again and again, you can just call them by name, and the whole block of code represented by that name is run. And functions can accept multiple values, they can return a value, and they are very useful in structured programming. In pointers, we are going to discuss the memory and memory addresses. Each variable stored in the computer has some memory address, and to get really quickly to that location, we are going to use something known as pointers. They are essentially addresses in the memory containing some kind of another variable, a special kind of variable, and they are useful if you want to have something known as direct memory access. Then we might be discussing structures, which are essentially a precursor to objects. In objects we have data as well as the function associated with that data, and in structures we only have data with that data, or some kind of a complicated data structure contained in some kind of a container. The primary focus is essentially how to write software programs to accomplish some task. As we know that a program is essentially a sequence of instructions that can be executed by a computer. So in exams and in midterm tests, the primary focus is you would be required to write some program which solves some kind of a problem. For example, you might be required to write a software program which would be computing something known as a Fibonacci series, or a factorial of some number, or maybe designing a simple calculator, or maybe designing a scientific calculator, because all these software which we see on our computer, they are written in some kind of a programming language. So if you want to get started in this how to develop these C programs, or C++ programs for that matter, you need to have some kind of a text editor and a compiler. We have a very good integrated development environment, something known as code blocks. And in code blocks, if you go to this website codeblocks.org, so you can download the software. If you go to downloads, and then if you select the download the binary release link, then you have a list of available downloads. Do not download the very first setup, because it only contains the integrated development environment but not the compiler, because a compiler actually translates whatever you write in your programming language to a language which a computer can understand. A computer only understands ones and zeros, or machine language for that matter. So since we would be writing known English words in our programming language, such as C++, computer doesn't understand that. Computer needs some kind of a compiler, as essentially another software, to translate whatever you have written as a sequence of instructions in that code of that program to a machine language. So what we need to do is we need to download this link, that code blocks 20.03, and it contains the C++ compiler built in over there. After downloading and installing this thing from FOSSHub or sourceforge.net, then you need to install this thing, and after installing this thing you will have a code block software installed in your computer. So if you go to code blocks software, you will have something known as a splash screen, something like that. Let me relaunch that again. If you go to code blocks and then select this, sorry, not this one, this one, so you will have a flash screen, something like that, and you will be seeing a kind of an integrated development environment. Here is the management panel, and you start over here, and here will be some logs, build messages, some error codes and something like that, and build logs, lots of things. As we go along, we probably would be discussing few of these things. So if you want to develop our first program, what we're going to do is we go to file, and then we select new, and then we select sorry, say that again, new, and then actually the shortcut key is Ctrl+Shift+N. so if I just carefully browse my mouse over there, and empty file, so if it's, or you can just press Ctrl+Shift+N, and then we need to save this file. Save file as, you can just save anywhere, make a new folder. Let's say the folder name is spring 2020, and then we name the file. The naming conventions would be discussed as time goes on, but do not start with a number, do not write some special characters, just write maybe file or example1 dot, that's the important part, cpp. Okay, cpp, so that the file would be saved as a C++ file, and if you click save, then we have example1.cpp in this text editor. We are going to write a code over there, and then we're going to run our very first program. When writing the program, keep in mind that C++ is case sensitive. That means that if you want to write something known as I'm going to delete that in a moment. If you write main, or if you write this thing, these two are two different words. So let's try writing our very first program, and what I'm going to do is going to print something on our console output, or that black and white DOS prompt output, so or command prompt output for that matter. We are going to write the hash key and going to write include, and then we have the angle brackets, and going to write IO stream header file. I'm going to discuss that in a moment what that means, and then I'm going to write integer main. I can write void over here, or I can just leave it empty. It means exactly the same thing. And then we write the curly brackets. One more thing, that these are round brackets, these are angle brackets, and these are curly brackets. So I'm going to write standard colon C out, and then going to write double quotes hello world. I mean, this is the classical first program in essentially every C language, or Python, or C++, or Visual Basic, and so on and so forth. So this is our very first program, and let's build this thing. If you go to build, and if we click this one, build and run, so it says well, it has a, well, forgive the antivirus software. This is a console output, and it says hello world. Whatever we have written in this double quotes is displayed over here, and these are essentially system messages. And it says press any key to continue. If I press any key to any key, this window would disappear. So if I one more thing to see, that the blinking cursor is at the next line. I mean the next line, I mean if you just ignore these things, the blinking cursor should have been over here, but we have written a special character \n, which represents a new line character. I'm going to discuss that in a moment. There are many others escape sequences. So for due to this \n, the cursor is at the next line. So let's discuss what we mean by all of these things. I want to repeat that once again, that when you are writing C++ programs, please remember that C++ is case sensitive. So make sure that you follow, I mean you just write everything in essentially lowercase, except when you have a very good reason to write capital letters. So this is our first program. The first line here is a preprocessor directive. A preprocessor directive is essentially a prerequisite. I mean, a simple explanation is since you are in electrical engineering program, it is understood and it is assumed that you already know the mathematics and physics of your 10th grade and 12th grade. From matriculation to intermediate, I mean, because they become the foundation upon which the future electrical engineering knowledge is built on. Similarly, the compiler doesn't know where that cout is, or what this cout is. Essentially it's a stream modifier, but we're going to discuss that what that is. But this thing is defined in this header file. So the first line in this source code is a preprocessor directive. That means that before processing the whole thing, we need to include, or we are saying to the compiler, please include whatever the functions or whatever the definitions are contained herein in your memory. So the first line in this source code is a preprocessor directive that tells a C++ compiler where to find the definition of this standard cout object that is used in this line. The identifier iostream is the name of a file in a standard C++ library. Every C++ program that has a standard input and output must include this preprocessor directive. Note that the hash sign is required to indicate the word include in a preprocessor directive. The angle brackets are required to indicate the word iostream, which iostream is essentially a short form for input and output stream, and this is the name of a standard C++ library file. I mean, as a C++ standard library is a huge library which has a huge amount of software already written. So in the first few weeks we are going to discuss how to make the software, and in the final weeks of this course we might be using the built-in facilities or built-in functions defined in the C++ standard library. The expression, this iostream, is known as a standard header. The second line is also required in this C++ program, and it tells where the program begins. The identifier main is the name of a function called the main function of the program. Every C++ program must have only one main function. The required parentheses or the brackets that follow the main indicate that it is a function, so that whenever you see a word and after that you see round brackets, they might contain something, they might not contain something, but whenever you see some round brackets or these parentheses, that indicate that that word represents a function name. The keyword int represents integer. It says that int stands for integer. It is used here to indicate the return type of the main function. I mean, I could have written over here something like, if the program has run successfully, I could have written 0, and after that you should write semicolon. That means that whenever the main function has concluded successfully, it should return 0, which is an integer. That means wherever the main function is called, I'm going to display that in a moment, how that main function is actually called. So whenever the main function is called and it has concluded successfully, it returns the code 0, and that 0 is an integer. So that when the program has finished running, it can return an integer value to the operating system to result some kind of resulting status. There are other codes whenever the program hasn't run successfully, or it might have thrown us some exception, but here the program has run successfully, so it returned 0. Okay, the last two lines constitute the actual body here. The last two lines constitute the actual body of the function. So the program body is a sequence of program statements enclosed in these two curly braces. These are round braces, these are curly braces. Whenever you open a bracket, make sure you do not forget to close the bracket. In this example, there is essentially just one statement. I mean, this thing is optional. Some compilers do expect return 0. For example, if you are using, instead of this code blocks, if you are using Visual C++, it might be expecting return 0 statement because you have written integer over here. That means that whenever you have defined a function which is returning some value, you have to return some value. In other compilers, this last line is essentially understood, so we don't need to write this line again and again. So there is essentially just, if you guys just delete this line, I mean it's superfluous at the moment. So this line is essentially just one line. This is a one line program. It says to send the string. A string means whatever is included in these two double quotes. To send the string hello world to the standard output stream object standard : C out. The single symbol, this symbol, represents the C++ output operator. When this statement executes, the characters enclosed in the quotation marks, these double quotes, sorry, are sent to the standard output device, which is essentially or usually the computer screen. Where rarely it might be a printer, or essentially we have like two outputs in our computer, essentially a computer and a computer monitor, or computer screen, or maybe a printer, or it might be a speaker as well. So, and input devices mean keyboard, mouse clicks, or microphone, or web camera, or maybe in a scanner. These are essentially input devices. So whenever we are saying that send this thing to the standard console output, to the standard output device, which usually means the screen. The last two characters here, the \n before the double quote, essentially this is the whole string coming from here to here, and this \n represents the new line character. It's not printed or it's not displayed on the screen, but whenever the output device encounters this character, it advances to the beginning of the next line of text on the screen. I mean, this thing is really similar to, if you are using, if you might have seen, I'm not expecting you to be, but if you might have seen some typewriter, there is a new line action on that typewriter. This \n does exactly like that. So finally, note that every program statement must end with a semicolon. If the compiler doesn't see a semicolon, it will throw up an error. If you notice that we have written 1, 2, and 3, 4, maybe 5 lines in this program, if I'm including the curly bracket as a separate line, but the compiler, I mean, this is for our own readability. If we want to make it simple for the users or for the viewers to see the program, we have to, you know, use these spaces, but the compiler simply ignores these kind of formatting. I mean, I could have written this program in just one line. I mean, obviously I need to write the preprocessor directive preceding the actual program, the main function code block, in a separate line, but after that I could write the whole program just like this. If I just press the delete key so that the next line comes up, then this thing, and if I keep on this thing, and if I go to end of this line and of course another delete key, so that I have the whole line is, I mean, the whole, essentially the whole program, I mean, excluding this preprocessor directive, it must be specified, or I mean, it must precede the main program or main code in a separate line, but our actual program is essentially just one line. So if we go to build, and if we click build and run, so we have sorry for the antivirus, we have the same output as we had before. Okay, so let's say I want to modify this program using something known as another line, something known as using namespace standard. Since it's a statement, it's not a preprocessor directive, it's a statement, so I need to terminate that statement with a semicolon. Then I write integer main, and just to make it simple to read, I want to do is what I want to do is I want to write each statement on a separate line, so that I want to delete this thing, see out, bear with me in a moment what I'm going to do, and this thing. Okay, so if I do not want my compiler, let me write it first and then I'm going to explain it in a moment. Let's say if I write prints hello world exclamation mark and so on and so forth. Okay, and then I write return. Once again, this is not really necessary, but it's a good practice since you have this, since we have defined our main function which returns some value, so obviously we need to explicitly define what value is going to return after successful completion. Okay, so the new thing which we have done, I mean we have done like 2 or 3 new things. We have written a line, something known as using namespace standard, using namespace std for short, and then the semicolon, which tells the compiler to C++ compiler. This line tells the C++ compiler, which is running behind the scene whenever we select build and so on and so forth. So it builds and runs this file. Okay, so and using the compiler, it translates this English or the C++ English into machine code. So we are telling the C++ compiler to apply the prefix is std : to resolve the names that needs prefixes. I'll bear with me what we mean by this. It allows to use cout in place of std : cout. This makes larger programs easier to read. We do not need to write standard : again and again after every cout or cn and so on and so forth. The fourth line, I mean sorry, the fourth line, 1 2 3 4, the fourth line, we have written this line. If you notice that this line is kind of grayed out because I have written double forward slash before that. So this thing is actually a comment. A comment in a program is essentially, you can just write anything in a comment, is essentially a string of characters that the preprocessor removes before the compiler compiles the programs. It is included to add explanation for anyone who is reading your program. In C++, any text that follows a double slash symbol up to the end of the line is a comment. You can also use something known as a C language. I mean, C language came first before C++, and essentially now C language is a subset of C++. So I can do this. I can write something like this. I mean, this thing has grayed out the whole thing. I can just write another comment and just close the comment using this. So I can just write another comment using a forward slash star. Just write whatever you want to write in there. The compiler is not going to read it. It's essentially any string of characters enclosed between these two symbols, forward slash star and then a star forward slash. These comments can essentially run over several lines. So I can just do, if you have like multiple text, so I can just write this comment is being continued. You can just write anything over here, and it's a good practice to write comments next to your code so that whoever is reading your code can actually understand what that code is doing. So I mean, you would be required in your exams to write actual code on paper or on computer depending on the conditions, and then you have to write the code which is actually readable and compilable by the C++ compiler. This line I have elaborated before what this return 0 does. So it's essentially optional because it's essentially understood, but some compilers do want it to be specified. It depends on what compiler you are using. Now, why we have written namespace. Before going into the detail of namespace, just imagine, or we know that whatever telephone numbers we have, maybe it might be a landline or it might be a mobile phone, these telephone numbers, if anybody is calling from outside, they have to attach a prefix of 92. That's our country code, Pakistan's country code 92. They might use 00 or plus before that if you are dialing internationally, but they have 92. So that means whatever mobile phone number I have, it is possible that another person in some other country might have the same number. But how do we differentiate between these two numbers is, let's say my mobile phone number is, I'm saying let's say, it's not actually this is, let's say my mobile phone number is for example, I'm going to write in this comment, for example 0300 and 123 4 5 6 7. It's not my number, it's just a dummy number. So let's say this is a number, and that if anybody is going to dial from internationally or some outside country, is going to dial is going to dial, what's he going to dial? Is going to dial plus 92, and I'm going to not write 0 over there. So that means this number is unique all over the world because it is now being attached with a prefix of plus 92. But this number, I mean, if I just delete this thing and I write 0 over there, or 0 is actually not part of it, but if you type 0, that means you are essentially out of your local exchange. So my actual number is actually 300 123 4 5 6 7. Okay, 300 is the telecom operator code, and this is my actual number. So it is possible that anywhere in some other country, this number obviously would be with some other person. How do we differentiate between these two numbers? Using prefixes. We have a network operator prefix and then we have a country prefix. Same thing goes with namespaces. A namespace is a named group of definitions. When objects that are defined with a namespace are used outside of that namespace, either their names must be prefixed with that name of the namespace, or they must be in a block that is preceded by using namespace statement, such as here we have used this statement using namespace standard. Namespaces make it possible for a program to use different objects with the same name, just as different people can have the same name. The cout object is defined within the namespace name standard, std for short, in the istream header file, so that we do not need to write cout and going to prefix it with the std : prefix. If I want to recompile this program, I'm going to do to build, but if I notice that these options are grayed out. Reason is, when we compiled the program earlier, it show the control has been transferred to this window. So I press any key or just close this window. That now if I go to build, now it says build and run, and it says 0 errors, and sorry once again for that antivirus software. And we see exactly the same output. That means the compiler did not look at whatever we have written in these comment lines. We can have multiple line comments, we can have single line comments with double slash, forward slash only, and then a whole program just ran just like before. Now let's close this window and going to discuss this thing, what that thing is. This symbol is known as the output operator in C++. It is also called the put operator or the stream insertion operator. If you look from a distance, it looks like some kind of an arrow. Okay, it inserts values into the output stream that is named on the left over here. We usually see the cout output stream, which usually refers to the computer screen. So the statement, if I write another statement like, or this is statement, or maybe like this, if I write cout and this insertion operator and I write 66, so that means it's going to display this number 66 on the screen. Let's see if it works. So if I just press build and run, there's a shortcut key over there. So I think I need to display, and it says hello world, which we have written over there, and it says 66 over there, and that's it. So the operator is something that performs an action on one or more objects. The output operator, we are talking about this operator, or the insertion operator, performs the action of sending the value of the expression listed on its right to the output stream listed on its left. So whatever is here is sent to whatever is over here. Since the direction of this action appears to be going from right to left, the symbol, I mean this kind of arrow symbol or double angular brackets, was chosen to represent it. It should remind you of some kind of an arrow pointing towards the left. The cout object is called a stream because output is sent and it flows like a stream. If several of things are inserted into the cout stream, they fall in line and one after the other as they are dropped into the stream, some kind of going from a river or something like that, like leaves falling from a tree into a natural flowing stream of water. The values that are inserted into the cout stream are displayed on the stream in that order. So let's say if I write something like this, if I write double quotes and I write, I'm intentionally writing like that to explain a concept, and I make another insertion operator and then write LO, and then computer doesn't know these words actually represent something. For computer, this is essentially a stream of characters, and I write RLG, WORLG, and then it has a semicolon, sorry, exclamation mark, and I write a new thing, something known as NL. Let's see how it works. So I think I probably did that. I'm going to do build and run, and this antivirus is going to, and we see exactly the same two line. I mean, this cout is here. If I can just zoom in over there, is it possible to do that? Okay, much better. So if I see this first cout, I mean this is essentially the comment. It is grayed out. Compiler doesn't even read it. It's for our own reading facilitation. This hello world is printed by this cout, and this hello world is printed by this cout. So and what we have noticed that these objects, whatever they are inserted right one after the other. Okay, so the output operator here is used in this line 1 2 3 4 times, dropping the 4 objects. The object number 1 is hell, I mean not that hell, HEL. The second object is this string literal, or going to discuss what these literals are. Essentially a group of characters, and then we have another object, and then we have another object into the output stream. The first 3 are strings that are attached or concatenated together, or maybe you can say that strung end to end to form a single string hello world. The fourth object is the stream manipulator object, and L, or end of line. It does the same as appending a new line character \n, but it does something else as well. So I mean it attaches a \n to this string, and it sends the print cursor to the beginning of the next line, which this \n actually did. And as endl has a \n built in, a new line character, and it does something known as flushing the output buffer. So whatever output is, these computers are really fast. We have like essentially gigabytes of memory and buffers which are sent from the compiled program to the screen. I mean, they have like billions of characters going in and billions of pixels, so it's not that significant. But whenever we have a data stream going to some output device, we could be having, or we do have, a memory space, something known as a buffer. So that, I mean, in the old days, whenever we had these command prompt or these text-based displays, it might be possible that data is coming in at a very fast speed, but it's not being displayed at that speed, so that the data coming in is really, I mean, it's in high volume, but it's being displayed at a slower rate, so that we need some kind of a storage space to store the characters which we haven't yet displayed. I mean, here the screens are really fast, so I mean, the role of that buffer is not much, because it's essentially whatever is we send to the screen is immediately almost displayed. But in the old days, whenever we had a text-based console outputs, which you might have seen in aeroplane ticketing agencies, or ticketing counters, I mean, they use some legacy systems, so they might be using some kind of the output buffers which store the data which has not yet displayed but is going to be displayed in some time. Okay, so I'm going to close this thing. These three objects, these HEL, LO, and WRLD, are known as string literals. Okay, string literals. Each literal consists of a sequence of characters delimited by quotation marks or double quotation marks, or the character. A character is an elementary symbol to use collectively to form a meaningful string. Let's say, I mean, H is a character, E is a character, L is a character, O is a character, and so on and so forth. I mean, English writers use the standard alphabet of 26 lowercase characters and 26 uppercase letters, along with 10 numbers and a collection of punctuation marks. But the thing to note is that these characters are stored in the computers as integers. Essentially, everything in a computer is a number. Everything. I mean, if you are seeing this mouse cursor, this mouse cursor is actually a bunch of numbers. Essentially, it's an object. It has the data as well as the function associated with it, as well as whatever it can do based on context. If you look at these characters behind the scene, they are essentially all numbers. Okay, so characters are stored in computers as numbers. A character set code is a table that lists the integer value for each character in a set. Most common is the ASCII code. You might have seen that, ASCII. You might want to look it up over the internet. Now actually Unicode is being used. So I mean, ASCII is short for American Standard Code for Information Interchange. It was essentially a 1 byte code, and then it was expanded to 2 bytes and then 4 bytes, and Unicode is depends on what language you are using. So essentially all the languages, or many languages of the world, are now represented in the computer in the form of Unicode characters. But we'll be seeing only English characters in this course. Okay, so new line character, this /n, is one of the non-printing characters. It is not displayed on the screen, but it has some behavior associated with it. It's a single character formed using a backslash and the letter n. There are several other characters formed this way, such as /t, which is a horizontal tab character. /a, a lead character, might be playing some sound or something like that. Backslash is also used to denote the two printing characters that could not otherwise be used using a string literal. I mean, if you want to display backslash, because backslash is essentially an escape sequence indicator. So let's say I want to display a backslash. So if I write one backslash, it's an escape sequence. So if I write, I mean, going to write somewhere else. Let's say I want to, instead of this comma, I want to display a backslash. I would write 2 backslashes because it's a rule. So if I want to display these 2 backslashes, let's build and run, and this antivirus is going to bugger us again. So sorry about that. So this thing is displaying a single backslash because the backslash itself is a escape character. So if you want to display a escape character, I mean this backslash, you need to write double backslashes. Okay, so characters can be used in a program statement as part of a string literal or as individual objects. When used individually, they must appear as character constant. A character constant is a character enclosed in single quotes, and as individual objects, character constants can be output the same way string literals are output using the same cout string modifier. So what I'm going to do is I'm going to, well, these comments are not needed at the moment, but it's a good practice to write comments. And this line is also, I'm just going to write this hello world once. I'm going to delete that, and then I'm going to write single characters. So make sure you understand what we are doing over here. I'm going to write over there as hello, and then I'm going to write W, and I'm going to write world, WORLD, but I'm going to use character constants, essentially a character enclosed in single quotes. Whenever we have multiple characters forming a string, we have to use double quotes, as here as hello W. But I'm going to write delete, and let's see, I want to attach another letter over here, so I'm going to put a space over here. It's not needed. So hello, another string, because I have multiple characters. I'm going to, this is a string literal, and this O is a character constant. So whenever we are using a single character, use a single quote. Whenever we are using multiple characters forming a string, use double quotes. Simple rule. And then we have to write another character, so put single quotes and the exclamation mark, and then we have to write another escape sequence, single quotes and \n, a new line character enclosed in single quotes. And let's see, hello world once again. So to keep in mind that the output operator can process, this output operator can process characters like these enclosed in single quotes, as well as string literals enclosed in double quotes. The three individual characters O and the exclamation mark and the \n, which is essentially a non-printing character, are concatenated or attached into the output the same way as the string literals hello W and RLT, and they all fall in line. If you have this thing first in and then essentially first out on the screen. We can also put numbers, something like any number over here. We can put something as let's delete that. I'm going to write something, this century ends December, or now I'm going to put some numbers like 3, 1. Essentially they are constants, okay, numeric literals essentially. But something else happens. Let me write it down first, 31, and then put a single space bar. That's a space bar character. And if I write like whenever this century is ending, it's like 2099, 2100. Okay, I'm going to write 2100. It's a 21st century, right? Okay, so I'm going to write NL, sorry, and ends with a semicolon. Let's see what's going to display. This century ends December 31st or 31, 2100. What actually happened over here is that whenever the numeric literals like this thing, the 3, 1 and this 2100, whatever numbers are passed to the output stream, they are automatically converted to string literals and concatenated the same way as characters. Note that the blank character must be passed explicitly to avoid having the digits run together. If I do not put this thing, then it will be something like that. It will be all without spaces. So if I just build and run, and it will look like this: 31 20 100. So it looks kind of confusing. So if you want to put some blank space and close that into a single quote, a single blank place, but let's say if you want to have double blank spaces, so what I'm going to do is I'm going to write a double blank place me it's a string literal, so double quotes 1 2, or maybe, or just put double blank spaces. So if had it been a single blank space, it would have been a single character, but now it's a string literal. So double spaces, let's see how it works. And we have double blank spaces over here.